Hi. Today I'm going to give a presentation on managing machine learning projects. Coming to the problem, in the fitness world, keeping people motivated is a big challenge. Many start out with great intentions, joining a gym, downloading an app, but most give up in just a few weeks. This isn't just tough for users who want results, it also means business lose out on long term clients. The usual solutions like sending out uh, reminders, they just don't cut it. Instead, there's a real opportunity in using machine learning to spot the warning signs and someone's about to give up and to offer the right kind of encouragement before it's too late. So that's why we are finding an opportunity here for a machine learning based dropout prediction model. So the problem again here is the program dropout. Study shows that 50 to 70% of new gym members quit within the first 3 months, which leads to poor outcome for users because they don't see a progress and they lose motivation. There is a high customer churn for business because they lose subscription, they see reduced engagement. How can ML help? Yes, ML can definitely help in predicting the dropout rate with the help of some measurable signals. What is the data availability we have? We have data with the help of fitness apps or gyms. They already collect a large set of data, or your mobile phones as well. They collect data in the form of usage, your steps, and all of those. So that can be counted. What are the methods we can use? We can use classification models like logistic regression, random forest, which can predict the dropout likelihood. The survival analysis model that can estimate when a user is most likely to quit so that we can put those interventions in place. And clustering to define different risk profiles of those users and then tailor those interventions based on their risk profiles. Predictive potential. So ML can detect those subtle patterns. Like if someone has kept some workouts uh, for a very long time, there is a high dropout risk there. Who cares? Actually, there are both the end users and the fitness business who care deeply about this problem. For the users, uh, dropouts lead to their frustration and unachieved goal, and they do not consider workout or going to the gym or maintaining a healthy lifestyle as something which they can engage with. For businesses, retention equals to revenue. So keeping even like 5 to 10% more users engaged can significantly increase their lifetime customer value. And for the industry, it's highly competitive fitness market nowadays. Improving engagement is a clear differentiator. Coming to the crisp DM model, there are certain metrics we would be walking through. Like first of all, which is the business understanding of this problem even more. So we are divided into three parts, which is defining the problem, defining the success, and identifying certain factors. Defining the problem, who are our target users, which are fitness app subscribers, gym members, or online training participants. The problem statement we already talked about, high dropout rates leads to poor user outcome and lost revenue. Why it matters, users fails to achieve goals. How it's solved today, generic push notifications, badges or group challenges, or certain times personal trainers follow-ups. Um, Gap is there is no personalization, no early warning system, no adaptive interventions. How do we define success? Reduce dropout rates by 10 to 15%. We are aiming just for 10 to 15% to increase engagement and improve overall customer lifetime value. The constraints which we have is data privacy, which is the health data available for the users, user acceptance, because there is a lot of notification for fatigue which we'll have to deal with, and balance between false positives and negatives. The outcome metrics is retention improvement, engagement uplift, like number of sessions per week improves, and the overall customer lifetime value. The output metrics will be measuring through precision, recall, FN score, AUC, ROC. The success targets is if F1 is greater than 0.75, there is a 10% improvement in 30-day retention after intervention. Some of the factors, domain expertise like behavioral science, motivation and habit formation, fitness coaching, and business. Potentially relevant factors for us for engagement: workouts per week, streaks, and skipped sessions. Variables calculating the steps per day, sleep, heart rate variability. Demographics, again, an important factor for calculation of all of this, which is the age, gender, fitness goals. App usage, how many times users log in, what features they are using, what is the session time, how much time they spend on the app. Behavioral signals like inactivity in streaks or intensity dropouts. The next is understanding a data a little bit more with the help of Chris TM. So we will be gathering how we would be gathering the data, how we'd be validating and exploring the data. Data sources are app usage, workout logs, variables, demographics. We'll be labeling data in the form of defining dropout as no activity for 14 consecutive days in the first 60 days. So we create binary labels like dropout equals to 1, retain equals to 0. Feature creation, engagement features like weekly activity trend, streak consistency, recovery features as an average sleep, heart rate variability, and rest days. And behavioral change signals, decrease in intensity, decline in logins. How do we validate this data? We would put a quality control, check for like missing values, example, skipped variable data or incomplete logs. Remove or impute erroneous data like 10 workout logs in 1 minute, which we do not want to use. Detect outliers, extreme sleep or activity levels. So we would also have to validate that sort of data. How would we resolve these issues? Apply imputation for missing sensor data, normalize across users relative to baseline, and ensuring consistent scales across different data sources before modeling. Now, coming to some statistical analysis, we would be distributing those key features, compare patterns between retained versus dropout. We'll do some correlation analysis as well. We'll be identifying patterns like early warning signals, drop in streaks, low app activity, subgroups, as in are beginners more likely to drop out and then advanced users. So we'll divide those into cohorts as well. Coming to data preparation, we would be definitely splitting our data first into 70% training, 50%, 15% validation, and 15% test. So this is using like time-based splits, like train on earlier weeks, test on later weeks to avoid leakage. We'll also be doing cross validation with k-fold validation for robustness. How do we determine our feature sets? There are a lot of features which we have: sessions per week, streak length, drop in activity, average steps per day, sleep duration, age, gender, fitness goals. All of those would be your features. We'll be selecting the features with the help of correlation analysis to drop redundant features and dimensionality reduction if feature set is high dimensional. How do we prepare for modeling? One hot encode categorical features like gender and goal type, normalize continuous features, which is like steps in HRV using Z score. We would also be handling the imbalance like oversampling or undersampling within the modeling itself. What is our solution validation plan? Like, how do we validate our plan overall? This is a five-step process we would be using to validate our overall plan. Like, formulate a hypothesis first. What is a hypothesis? If we can predict users at risk of dropout within the first 2 weeks and deliver them interventions, then overall retention will improve by at least 10%. So that's our hypothesis. How do we test the hypothesis now? We deploy the dropout prediction model on a pilot group of users. We'll be splitting them into two groups. One is an intervention group receiving personalized nudges, and then there is a control group which receives standard generic reminders. We'll be analyzing our learnings, comparing retention rates, engagement metrics, and satisfaction between these two groups, measuring the model performance, and collecting qualitative feedback. We'll decide to continue or pivot based on if retention uplift is greater than 10% and users find intervention motivating, we'll scale up. If results are weak or users dislike nudges, we'll refine our intervention strategy. We refine hypothesis and repeat. We'll adjust our dropout definition, like an activity threshold, test new intervention strategies. We'll rerun this validation cycle until retention improvements are consistent. How do we design our ML system based on three different approaches? For compute location, we'll be choosing cloud since We want to centralize the data or feature store and scale easily, and latency needs are minutes and not milliseconds, so we'll be storing in cloud. A learning mode would be offline, which is simpler and stable for our first version. Retrain weekly, bi-weekly to handle the drift, and upgrade to incremental later if needed. A prediction mode would be hybrid on the basis of both batch and selective. Online, nightly batch risk scores drive most intervention and trigger on-demand scoring only on key ones like missed workout, so that they are provided timely nudges. What are the potential risk when we are moving to production? There are three different potential risks, which is training, serving skew, data drift, and latency. Training serving skew is the data used training during training looks different from the data when we are actually making predictions in production. Why this happens is because of different pipeline for training versus serving. Some would be missing variable data at live scoring, or app feature also changes. Impact as model accuracy drops immediately after deployment because of it seeing a different world than what it was trained on. Data drift, the distribution of input data shifts over time. There are seasonal changes. For example, January there are more workouts. On other parts of the year there are less workout. Impact, the model prediction gradually becomes less reliable. Latency, real-time predictions like detecting a missed workout may be too slow. Wide occurs heavy feature computation at request time, and if the impact is if the nudges are played, they lose the effectiveness. Example like reminders come hours after the miss session. There is no point of those reminders then. That's it for how we are managing this problem statement and the solution. Thank you.